Hello and welcome back to part 2 of Virtual Physical Science. We were talking about energy, and unfortunately for you guys, it's time for a little bit of math. Alright? Two of the kinds of energy we talked about last time have simple mathematical formulas that we can use to calculate them. KE, which stands for kinetic energy, and GPE, which stands for gravitational potential energy. Okay, kinetic energy, you can find the kinetic energy of something by multiplying 1/2 by its mass, m is for mass, times its velocity squared. Okay, v for velocity. You can find the gravitational potential energy of something by multiplying its mass, m is still for mass here, times g, which we know is pretty close to 10 meters per second squared, times h. H, what do you think h represents? Right, the height of the object from the ground or from wherever it is that it can fall to. Alright, so let's start out with an example of calculating kinetic energy. Let's say Mr. Kolpak, who weighs about, who has a mass of about 85 kilos, finds himself moving at 5 meters per second. 5 meters per second is about, 18 kilometers per hour? Pretty reasonable speed. So how much kinetic energy does Mr. Kolpak have? If he has a mass of 85 kg and a velocity of 5 meters per second. Pause now and you try it. Try calculating how much kinetic energy I would have. Alright, how did you do? Well, let's see how it works out. Formula says that my kinetic energy would be 1/2 my mass times my velocity squared. That's 1/2 times 85, my mass, times 5 squared. What's 5 squared? Well, 5 squared is the same as 5 times 5, right? 5 times 5 is just 25. Alright, now it may be calculator time depending on how good your mental math is. If you multiply that all out, 1062.5. And then what units does energy have? We haven't learned that yet. Energy is usually measured in joules. It's not spelled with a W like jewelry. It's spelled funny, J-O-U-L-E-S. It's named after a person, James Joule, a British scientist in the 1800s who studied energy and work and power. Okay, so we use his name as the unit for energy, and we abbreviate it with just a big J. Okay, so Mr. Kolpak would have 1062.5 joules. Now, what would happen to my energy if I ran twice as fast? What would happen if my speed was 10 meters per second? If I double my speed, will I double my kinetic energy? That's right. No, I won't, because my speed has to be squared. And so doubling my speed is going to do more than double my energy. In this case, my kinetic energy is going to be 1/2 85 times 10 squared. What's 10 squared? Right, that's easy. It's 100. Okay, so in this case, my kinetic energy would be 4,250 joules. Not twice as much. 4 times as much. Okay? And that always works. If I double my speed from 5 to 10, I'm going to quadruple or multiply by 4 my kinetic energy. Just an interesting side note, the Earth moving around the Sun has a lot of kinetic energy. 2.7 times 10 to the 33rd joules. Right, the Earth is big and it's moving fast. The bigger something is, the more massive it is, the more kinetic energy it's going to have. The faster it moves, the more kinetic energy it's going to have. Alright? So if you had trouble with that, go back and watch this again and see if you can understand how we calculated kinetic energy in these two examples. Okay? And I'm going to stop here, and in the next part, in part 3 of Virtual Physical Science Energy, we're going to watch an example on gravitational potential energy. I'll see you there. Kolpak out.